So for this problem, to find the number of terms in the geometric sequence, so this is now the formula for the geometric sequence. We have a sub n equals a sub 1 times r to the power n minus 1. So from this given, this is the first term, a sub 1, the second term, that's a sub 2, then the third term, and this is now the last term, that's a sub n. So from this formula, so a sub n equals negative 78,732. Then for a sub 1, so that's positive 4. Then for r is the common ratio. So we can find r using a sub 2 divide by a sub 1. So since a sub 2 is negative 12 over the a sub 1, that's positive 4. So therefore the common ratio is negative 3. Then n for the number of terms. So since we're looking for the number of terms, so therefore n is the unknown. So to find out the number of terms based from this given using this formula, so a sub n is equal to negative 78,732, then equals a sub 1, that's positive 4, 10 times the common ratio, that's negative 3, then to the power n minus 1. So n minus 1. Then to simplify, so we need to divide both sides by this number. So divide by 4, divide by 4. So cancel. So we have now negative 78,732 divided by 4. So that's negative 19,683. So negative 19,683 then equals, so for this negative 3 to the power n minus 1, then this time to solve for n, so we're going to use the natural logarithm. So we need to ln both sides. So we have ln. Then we need to ignore the negative because there is no value for ln of negative numbers. So this becomes ln 19,683, then equals ln, then again we need to ignore the negative. So we have 3, then n minus 1. Then using now the property of logarithm, the power property, so we have ln, then 19,683, then equals, so for the power property, this exponent placed before ln, so this becomes n minus 1, then times ln of positive 3, then divide both sides by ln3, divide by ln3, so cancel. So this ln 19,683 divided by ln3. So we have ln 19,683, then divide by ln 3. So that's 9. So this is equal to 9, then equals n minus 1. So we still have n minus 1. Then to solve for n, transpose this negative 1. So we have 9 plus 1 equals n. So therefore, there are 10 terms on this geometric sequence.